Hello, welcome to episode 6A. And today I'm going to actually be heading on to what I did in the last episode, which is center of mass, except this time I'm going to be talking about the center of mass of a continuous sort of mass. So what do I mean by that? So we have our coordinates, right? X, Y, Z. And we have some blob. Just a blob, a thing with some mass, right? And how do we go about finding the center mass of something like this? Well, we can basically take our blob and we can cut it into little chunks, right? And each chunk has a mass, right? And so we take the sum of all of these little chunks from n to I. And essentially as these chunks, right? So as these, this isn't like mathematical notation, but essentially as these chunks approach 0 and as n approaches infinity, right? Well, we get pretty much an infinite chunk sum over tiny chunks. Well, what is that? And well, that's going to be an integral over dm over our object O, right? And what is this? Well, that's going to be the total mass, right? That's going to constitute the total mass of our object. And what about this sum here of MIRI? What happens? This is going to transform in the exact same way into an integral over our object of some function. So some function of r dm, right? And so the center mass of our object is this integral dm over f dm. And so usually this f is not that complicated, but yeah, that's pretty much how it goes. Maybe we'll see some. I'll show some examples soon, right after this. But this is sort of the way you want to think about finding the center mass of objects. And then the same applies with momentum is equal to m times r dot. And then also we have the forces inside the object are conserved. So hope that makes sense. Don't think I have anything else to say. So yeah, in the next video we'll look at finding the center mass of some small objects. And we'll start looking into solving some problems with this.